If you think about it, anything that you've ever used was designed by somebody.
Growing up, I was always a Lego kid, and I liked to know how things work, how to build things, take things apart, and how to make them.
I really like the idea of designing something, a product, creating it, prototyping it, and being able to physically hold what I designed from scratch.
Product design is unique in its own set, but it's also like a jack of all trades.
Product design is a blend of art and engineering. We want people to understand that product design is multifaceted. There's a lot of things that go into product design, so you don't have to worry about coming to us with the exact right background.
The Product Design Engineering Technology program teaches students how to solve problems and then destroying those problems by making a new product introduction. We try to have design thinking as the foundation of all of our courses.
Design thinking takes all of the creative stuff, but eventually transitions you into the fact that you have to solve the problem.
It's solving a problem, but solving it uniquely.
The first phase of design thinking is called empathize, and that's the phase where the designer tries to get into the head of the user. So we try to study what the user is doing, the kinds of problems that they encounter, and get to the root cause of what their actual problem is.
Learning your customer, figuring out what they want to do.
Narrow down the problem by asking the customer base, what is the problem with? What issues are you having?
Then we got to go through the define phase. And that's kind of where we think that we really like our product design program, because it allows you to come from all of those different backgrounds, create ideas. We have very creative people all over the place. We have students coming in from pharmacy and optometry. Come in, share with us, and then we're going to give you a tool set that says, now, solve the problem.
The designer takes the customer needs statements and tries to boil that down into measurable, specific outcomes that if the product achieves those outcomes, we will know for sure that we have satisfied the customer's goals. The third phase of design thinking is my personal favorite, which is ideation. And that's where we use the criteria that we identified in the second step, define, to generate as many incredibly crazy ideas as possible that are all pointed back to those measurable criteria.
Most exciting part is just being able to work with everyone, being able to see, this one way, please help me, like what do you see? And then they'll give another idea, and then you just kind of stem off of that and build off of that. More brains is better than one.
The reason why we strive for crazy ideas if possible is because in a collaborative environment, the more crazy ideas you get, the better ideas you'll get overall, because somebody's crazy idea causes somebody else to think of something that they wouldn't have otherwise thought of. After you develop a whole bunch of ideas and you've run them through a tournament structure to try to figure out which ones are the good ideas and which ones are the okay ideas and which ones are the really bad ideas, then you have to move into the next phase, which is where you build a prototype.
Conceptualization, that's where all the energy is, all the fun is, that's where the ideas are flowing, and then we get to the not so glamorous side of, now make that work.
I had to make a prototype stand for PlayStation out of basic cardboard, foam core, sticks.
The makerspace is a lab that's open to any student at Ferris. The purpose of the makerspace is to give advanced access to tools that students wouldn't necessarily otherwise be able to get access to.
The concept was, let's give them the machines and then get out of the way.
I use the 3D printers so much, about every day.
One thing that separates our makerspace from a lot of other academic makerspaces is that it's completely free for students to use.
You get to physically take your design and say, wow, I made this, it came from my head, now I'm holding it in my hands.
And then go back to the user and try to see what you learned from building that prototype. And that's the final phase, which is called test.
Sometimes I see an issue that they have, they don't even see that they have an issue. Seeing that and then taking my prototype and then make it even better.
The graduates we produce face almost limitless possibilities.
I already have a job lined up with General Motors.
I'll be going to work full-time at Hayworth. It's an engineering designer position in their tailored solutions department.
I'm going to actually be working for Magna. It's a company called Lexmark. It's an injection molding facility. They make exterior trim parts.
My favorite part about teaching, by far, is being able to enter into the specific geekiness of all my students. If somebody's super into acoustic guitars, they figure out how to design their own, they figure out how to make their own, and I get to sort of just be a guide to help them.
We're not really artists, we're not really mechanical engineers, We're kind of this hybrid in the middle, but that's exactly what we need sometimes.